Good afternoon, everybody. We are Hawkeye Technologies. As you know, we are the VPI group here in the 411-450 course, and we have 6 members, so I'll just be up here presenting today by myself. But to introduce all the members that we have Tony Butcher, we have myself, Nick Delcor, Zach Carnahan, Josh Schleichman, Breck Asino, and Sam Schreiber. We are working with Dr. Nate Hartman. As most of you know him, you've probably taken some courses. And we're also working with Professor Davis out at the airport. He works in the Hangar of the Future, which has been out there for a few years now, so it's not so much Hangar of the Future, but it is a really cool place if you haven't been there yet. We are also working with the PLM Center for Excellence, which is the PLM VPI Center lab that companies donate money to if they like kind of what we're doing in the PLM program. They'll come to recruit directly from there. Currently on this project, we're working with Cessna, who is a company under Textron. Most of you are familiar with most Textron products, such as, they have Cessna, they have Bell Helicopter, they also are over E-Z-Go, who make the golf carts and everything like that. But we're working specifically with Cessna in our model-based work instructions for aircraft. We are a legacy project, so as you know, we've had a few different iterations of work instructions under aeronautics. A lot of groups have worked with delivery systems on how to go about doing that, different modes of doing that. Our group has specifically designed a way to digest a lot of the information, what's the best way to do that. Now, this is previously what aircraft mechanics and technicians are using at Cessna. This is an assembly that they have to work with on a daily basis. And as you can see in the 2D format, it's very convoluted. It was really hard to understand. There's a lot of information in one image. So what we're doing is trying to create a 3D way, an animation versus static views. We tested 2 different ways. We have high level of detail, low level of detail, animation, and static views. And we're trying to come up with the best combination of those. This is an example of our high level detail assembly. So what you just saw in that 2D assembly, this is it in the 3D format. And we modeled this out using calipers, taking the exact part. Now for the low level of detail, we subtract a lot of the geometry. We take away some of the curves, some of the features to make a lighter file. Because we want to find that happy medium between how much information we need to convey through the screen and how light we can make the file, because as you know, aircraft have thousands upon thousands of parts. The PDM systems have to be very strong. The animation software we used was Cortana 3D. This is a little demo of what it is. It's basically a way that we can visualize an assembly or disassembly through the screen easily enough that people can understand. We have the parts kind of vanishing away, showing that you don't need to use that part anymore, the exact parts, different features. For a low level of detail, as you can see, this is what we use in our specific testing. This is what the students saw right before they had to go and actually disassemble the part. And as you can see, in the low level of detail, very simple geometry. So we want to see how they would be able to interpret that and relate those parts they see onto the screen onto the actual physical piece they had to work with. How we move into our high level of detail, you can see all the curves coming about, all the chamfers, all the surfaces. Much more complex, but yet easier to relate to the actual physical part they have to work with. So we're trying to find that happy medium in there. And we also, the alternative to these animations that you're seeing right now are static views, which are basically almost screenshots of what we were doing. This was our testing area. As you can see, we had the student work in this one area around here, and the computer was actually around the wall to the other work assembly area. And that's because Cessna specifically asked us to have a walking distance between the computer and the physical piece they had to work on, because most of their technicians walk about 50 feet from the computer screen to the actual plane. And as you can see, one of our students now, this is a test subject working with the actual 3D software. We gave them about a 20-second training process on how to pan, zoom, rotate the feature. Everybody understood it. I think we had something like a 98% said they understood the software perfectly fine, and they were able to use it right off the bat. Here was our physical piece. We limited the amount of tools they could use so we could control the actual subjects. They couldn't, if one subject was more experienced than another, they'd know the specific part to go and work with the piece. So we limited the tools that they could use, and this is the actual part. And as you can see, it is very complex. So this is another test subject, physically working on the part. We had about 6 steps that they had to do in order to completely disassemble the part. And in those 6 steps, I mean, it had to take off a complex clamping system. They had to remove certain features and interior features of this pump and oil assembly. As you can see, we had to monitor this process to make sure they were doing everything correctly. We wanted to make sure all our test subjects stayed within the actual grounds of what we needed them to, so all our testing, and we wouldn't have any outliers. We only had one student do one more disassembly than they should have. They started taking off bolts to another part, but they previously completed the entire assembly that we wanted them to. So for our testing results, we had 34 test subjects. 4 of them were FAA certified. They came from 3 different backgrounds, mostly aircraft maintenance, aircraft technicians. We also had aviation maintenance. We had experience range from 0 to 13 years. We had some of those FAA certified are veterans, so they did work in the aeronautical field previously to doing this test. We also gave them subjective questions. How did you like it? You know, what did you think about it? 70% came back and they said they preferred the animation over the static views, showing that that gave them a better representation of what they needed to do. And down here, 91% said that the 3D model helped aid them in this process over the 2D, what they were previously using. We do have a final presentation in Stewart 322. It's on December 6th at 10 a.m. You are more than welcome to come. Let us know if you'd like to join us and for our final data and findings and go through everything we are doing there. And we also have a website, Hawkeye Tech 411, where we'll be constantly updating all our data, keeping everything in check, because our representatives at Cessna and Textron are also relating back to that website so they can check our progress. So thank you very much for Hawkeye Technologies, and we hope to see you guys at our final presentation.